Hey guys, thank you so much for joining us today for the How to Optimize Your 3D Printing Workflows. My name is Janet. I head up sales and marketing here at LINK3D. And Shane and I actually took the time to put this together because he's been working in the additive manufacturing space for as long as I've known him, working with a lot of OEMs, service bureaus, and we thought maybe it might be a good idea to bring all of his insights and lessons learned together and share this with you guys. So giving it up to Shane, the CEO of Link3D.
Thank you, Janet. So hello, everyone. It's always weird doing webinars because I feel like I'm just talking to a computer screen. It's like talking to a wall with no interaction. I'm more of a one-on-one kind of guy, but no matter where you are in the world, I just want to thank you so much for joining. I'm going to try and keep this short and brief, under a half hour, because I know you probably all are very busy building parts. So, and like Janet said, I've been in the space quite a while, and after speaking with dozens of OEMs and service bureaus across the globe the last 7 or 8 years, I can't even remember how many years, we kind of found that most companies and people are in the same boat, right? So we're all trying to get the best return on our investment from additive. And it seems like everyone's constantly striving to develop and build innovative products and reduce time spent iterating, producing, and delivering prototypes. And maybe one of the most important is to reduce the costs incurred from these machines and the materials and reduce our organizational drag. So that's kind of my insight over the last few years. And obviously we put together the software company called Linked, and we have a product called Digital Factory. And I'm going to really steer away from the product today and try to just talk more high level about some of our findings. And please ask questions or email us. I want this to be an open forum, a think tank, not me just directing my opinions and thoughts, but more of a collaborative effort between everyone. So again, before I get started, I'll tell you guys just a little bit about myself. So some of you may or may not know a company called Within Technologies. I was a part of that software company in London in the mid 2000s or early 2000s. And I specialized in topological optimization and primarily for metal additive production. And then I did a little stint at Autodesk, where I was an additive evangelist, a business development guy, and a product architect. And then I started back on the journey of building software, and that's where I am today. So the 4 things I kind of want to cover from a high level point are the stages of adoption that most of us are in our current additive workflows. What do the day-to-day operational challenges look like for guys like us? And what are the opportunities that we all see in additive? Just a quick glimpse at the current technology landscape. And I want to talk a little bit about how we've seen companies like a lot of yours optimize for 3D printing. So where are you in the additive journey? So no matter where you are in adopting additive, the day-to-day process and the end goals can somewhat all look quite similar. We all want to simplify an extremely comprehensive workflow where we can leverage our internal facilities productions. We can curate and develop long-lasting relationships with service bureau partners. And we want to hire and manage multiple engineers and operational personnel required to build and scale out our additive manufacturing ecosystems. So from proving out time studies and benchmarks to building out maybe your first COE and trying to figure out that special recipe for success. And finally, we all want to move into scaling out our entire operation, maybe across our regional territories or across the globe, to take advantage of what we're calling the last mile delivery and achieve on-demand additive manufacturing. By no means are these stages some type of concrete definition. It's kind of just what we've come up with And we see most companies fall in three different stages: the proof of concept stage, the building stage, or the scaling stage. So the first thing I want to talk about is the proof of concept stage. So really what we see here are organizations working with machine manufacturers or maybe service bureaus to prove out the economics of additive. And this is quite low risk in execution, and they can really prove out if additive is economically feasible for their specific use case. By working with machine manufacturers or service bureaus, we can develop benchmarks that are focused on feasibility and the possibility of the part print. We can also look at time studies and figure out how long it actually takes to build this actual part. So once additive is basically proven to be ideal or somewhat ideal, the main issues companies are facing is then building the know-how. So therefore, it kind of prompts them over to the building stage. So the primary goal, at least from our opinion of this stage, is to focus on the construction of additive know-how and figure out, again, that recipe for success. So this is quite a challenging phase, and it kind of starts with hiring the right type of additive talent, then developing a repeatable workflow, and understanding unlocking the capabilities of your new machines is quite crucial. So during this process, workflow is still rather simple. However, as you start scaling and hiring more people and defining more roles and purchasing new equipment and offering more services, whether it be to internal, external clients, the workflow from what we've seen starts to get quite complex. This phase is still relatively medium risk. It does obviously involve, capital investment, but ensuring that your center of excellence or your facilities break even, actually ensuring that your COE can break even and potentially even turn a profit will indicate, if your additive ecosystem was successful in its rollout. So preparing to scale to push the limits of product innovation and supply chain optimization pushes the company to the next step. So we're calling that scaling. So you really got to figure out the recipe. And I wish there was a step-by-step instruction. I'm sure we all do. But once you've kind of locked down that flow and that recipe to break even or even generate profit, you can really start moving into the scaling. So I just wanted to reiterate that point. So finally, once you get to the scaling process, the additive economic model basically has been proven out. And the organization wants to take advantage of building this on-demand distributed manufacturing network to benefit from last mile delivery. This stage obviously is very capital intensive. Well, as you're going through expansion, you're also trying to generate enough internal demand and external demand from your internal, external clients. And that could be challenging in itself. The workflow systems during the building phase need to scale and adapt to this new operational workflow that you moved into during scaling. And really what we see during the scaling process is actually really simple. Companies are adding more facilities, they're adding more printers, they're exploring or printing with new types of materials, be it polymer or metal alloys or some other type of composite, and they're adding more people to the mix. So, just like anything in life, more of everything, it's going to introduce a lot of challenges. And we have a lot of challenges ahead of us, especially if a lot of our end goals is to create series produced parts that essentially can achieve 100% repeatability each time. So no matter where you are in the journey to prove out additive, again, the day-to-day challenges remain similar across many organizations. So the complexity of your ecosystem and workflow will be dependent on a number of factors. And I could go on probably all day about this, but some of the high-level examples that we think are quite dominant, are something like, how many engineers do you actually have designing for additive? What's the number of internal facilities you operate? And how many vendor relationships are you currently managing? What type of products do you design and what's the nature of your actual business? I think another really key one is what type of softwares are you using and what type of hardware are you adopting? And do they have the actual ability to connect with one another to close this so-called digital thread we keep hearing about? And lastly, one that we constantly hear that becomes complex as you scale is how many parts are you printing on a daily, weekly, or monthly basis? So these are just some things that I wanted everyone to think about on the webinar. Let's sit in, and I'm sure each and every one of you, or most of us, have experienced or asked these questions or seen these examples before. So let's dive into the typical workflow that we've seen thus far. So the first stage we're calling is the part design. Now, obviously, there's a lot of collaboration and a lot of work that goes into this between meteorologists and engineers and CFD guys and FEA guys and application engineers. We get that. But once the design has been finalized, be it a prototype, a fixture, or a jig, a tool, or even a series produced part, knowing where and how to submit orders can actually be time consuming and challenging. And I always found this to be quite shocking when I've gone into companies talking to engineers who don't even realize that their company owns, millions of dollars worth of printers. It kind of blows my mind. And we've been on site where guys didn't even realize the type of materials or machines or post-processing or experts they had right down the road. The second stage is the connection point between engineers and application engineers. So once an engineer finally into who the order should be placed with, application engineers on the facility side also experience difficulties. And some of the difficulties we've seen that the guys actually in the thick of it running the machine are things like receiving corrupted files, having to go manually back and forth with engineers constantly to figure out how to correct a file or to figure out if the part was designed for the right material, so on and so forth. Also, generating quotes or cost sheets seems to be an extremely arduous process for most companies. Also, forecasting material usage. And lastly, generating accurate build and lead time estimations. So as we move into the third stage, we're calling it the build preparation stage. And after orders have been placed, the next important step is to really optimize the 3D production workflow. So during the build planning stage, you have to ask yourself things like, how do we ensure we're maximizing the capacity of each run? How do we achieve 100% repeatability for series produced parts? How do we understand the right type of orientation? How do we understand if we're scripting out the right support structures? There's a whole bunch of different things that become very manual and very arduous in the build planning stage. And from what we've seen, much of the build preparation is actually conducted in a manual format. And we really wanted to look and see how companies were introducing automation into this process to speed up the production planning. The fourth stage is what we call the machine scheduling. So, we see companies, very large multinational companies, where I'm actually in Germany right now at one of them, using Excel sheets or whiteboards to actually manage their production and delivery dates. There's nothing wrong with Excel and there's nothing wrong with whiteboards. And it could be a quick fix for planning, but data becomes quite disconnected. It's difficult to tie all this data collected and discover actionable insights to improve your actual internal processes. So we're seeing and we're calling for the need of a real-time system that will help your company actually make key actionable insights into your business to make decisions each day. The ability to know when machines are running or experiencing downtime is quite simple, but it doesn't really exist today, especially agnostically, and it's crucial for the production planning. Being able to simply reroute part orders and utilize spare capacity of other machines, whether it be on the same floor or in a different country, is also extremely important to meet deadlines and to provide the best customer experience with users of additive, whether it be internally or externally. And the fifth stage is the reordering of parts in what we call some type of digital part inventory or digital catalog. So once parts have been certified for production, how do they handle reorders, ensuring that the parts metadata is accurate and always repeatable? And I think this is something we're all trying to figure out. So currently, we see companies storing data in legacy systems or FTP sites or some type of cloud management system, and it doesn't really allow companies to adopt true on-demand manufacturing. And we believe that on-demand manufacturing is crucial, is absolutely crucial, and it's necessary for companies to unlock the promised benefits of additive. You know, many OEMs are striving to reduce inventory, and they're striving to reduce part obsolescence and warehousing costs. And in some cases, we've seen promises up to 50%. But without a connected system, without being able to achieve true on-demand manufacturing, I don't believe that can ever happen. So with disconnected systems such as CADs or PLMs or ERPs, it's quite difficult for companies to track metrics, to calculate the return on investment, or to even run a lean shop to manage their P&L. Again, it's just very hard for them to take actionable insights to improve on this process that's so new to all of us. So since there's so many steps in between so many software systems, really any manual process breaks the digital thread, hence adding security risks or manual processes or longer turnaround times. So, you know, what's out there today? As you can see, there's a lot of challenges ahead of us. I wish I had all the answers. But, you know, there are companies out there that have begun working on solutions to help us get on our way. So I'm sure every one of us knows every company up here. We're probably all users of something here. But as you can see, the landscape is still relatively disconnected. There are so many types of software systems out there for each part of this process, but there's really nothing yet that can tie them all together. And I'm not saying that they're not working on this, but I think they need to work quicker. You know, a lot of these guys are pushing forward, but we're still not there. What we believe, and what many people I've spoken to believe, is that the industry needs more collaboration between software and hardware companies to close this digital thread. In addition to all the day-to-day challenges that you guys face just to produce a part, we know that you're bombarded with tons of data-intensive tasks. We believe these tasks can be improved upon with smart automated additive systems that introduce algorithmic-based solutions and even machine learning to help you move from a manual arduous process to more of a knowledge-based decision-making process. And I think it's all of our responsibility as users in the space and believers in the space to encourage our partners, whether they're machine makers or software companies, to partner and collaborate to connect this digital thread. And together, I think we can all then experience the true benefits of Industry 4.0. So again, I want to reiterate, the digital thread is disconnected. I've said it 100 times, and if you ever meet me in person or if I know you, you've probably heard me say this a bunch, but it really does make it difficult for companies to optimize our workflows, and there must be an alternative. So as I mentioned before, the day-to-day challenges that we all face to produce parts, they're filled with plenty of data-intensive tasks. And again, smart systems that introduce algorithmic-based automation tools will help companies move towards, again, knowledge-based decision-making activities. And I will hone in and repeat that till I'm blue in the face, probably. So to highlight what's possible today, I'm going to walk you through a couple of different scenarios. I'm going to touch back on those 5 points I made earlier, and then we'll wrap it up. But again, during the first stage, when companies are placing orders, they can actually take advantage of order routing systems today that apply intensive algorithms that can help match their orders with optimal facilities, machines, materials, or even outside suppliers in a matter of seconds. So imagine if you can actually match your order with the right partner based on a whole load of things like materials, machine models, maybe AM technology or post-processing services. Or what if you can even specify things like your lead time or your delivery date? Knowing what resources are available to you without having to dig through static legacy systems or go to the good old boys network can help you save valuable time. And again, finally, instead of this manual handoff from one engineer to the next or one engineer to the application engineer, we need things as simple as real-time collaboration tools that allow engineers to directly communicate with each other, whether it be their departments or engineers to facilities, to speed up the process of last-minute changes and eliminate the organizational drag that so many of us face today. So as you can see here, once orders have been placed, we move into the second stage. And there's, again, typically there's a manual handoff between engineering departments and application engineers, which automatically causes a disconnect in the digital thread. And as I highlighted before, an ordering collaboration tool to enhance communication is key, again, to gaining quicker turnaround time. So all this being said, I think one of the most time-consuming components of additive is figuring out costing. Over the last 8 or 9 years, I've seen all sorts of different ways of costing, from service bureaus to OEMs, from building a part and weighing them on a scale, to charging just based on the machine time, to crazy formulas on Excel sheet. And I think we're missing something here. I think systems need to be smarter. When an engineer wants to simply figure out a quick reference point for how much a part can cost, wouldn't it be great if we had some type of automated quoting solution that eliminates manual back and forth, and an engineer, based on a material or a lead time or the volume size of the part or whatever it may be, he can actually see an instant quote. This way he can take it back to his team and really determine if additive is the economic solution to build this part. Depending on your business or your company's structure, you may want to automate, you may want to estimate costs and generate quotes in real time, again, without human intervention. But you may want to receive a part order, and maybe this is for a more complex build of some type of microstructure or generatively designed part or some type of metal alloy, and you want to do some internal cost estimations, like understanding how long will this take to build, or how much material will this use, and what is the optimal orientation for this part. And all of these different factors combined with post-processing and even automating post-processing will give you the actual generated and accurate price. Then you could submit it back to your department or back to your customer. And I just, going off script a little bit, I think one of the most important things about additive is getting costing right. And I'm not saying we're the only solution out there, but understanding how to actually price out part builds from the build through post-processing through manual CAD time is extremely important, and it's crucial to the bottom line of the companies we work with today. And I think having a machine learning system that can simulate layer by layer and forecast the amount of material being used and take into consideration build parameters and look at automating post-processing will actually give us the most accurate pricing for our part production. And and this is something that I would love to open up. I wish we could just have all 50-something people talking, but the next stage we talk about is the build planning stage. And we believe with smart tools, smart build planning tools, we could shave off hours of production planning time. Having multiple optimized orientation strategies like minimize the runtime or reduce the Z height direction or minimize build failures. Having these different nesting strategies and orientation strategies can give all of us a great deal of insight into the planning process. So, for example, let's say you have many small orders, and in each order you have 1 to 2 parts. If there was a tool that could help batch multiple orders together that considers the most optimal nesting strategy for the parameters and the material and the geometries, we believe application engineers could maximize their chambers while still meeting their production goals. And let's say you have large orders, in the hundreds or thousands of parts. A build planning tool can truly help determine the number of runs it's going to be required to fulfill this order. And managing this optimization equation on Excel or whiteboard can be quite hectic and maybe doable, but with the smart system powering, this nesting strategy and this build strategy, companies can optimize the production throughput and achieve a higher ROI. And I think this, we need to start moving away from the manual artistic approach to more of an automated approach if we really want to achieve serious production on a mass scale in our industry, along with several other things. But so once you've planned your build, you're basically ready to queue that order up, and that moves us into the 4th stage. So whether you're using, again, Excel or whiteboard or multiple proprietary software systems to manage your machine schedule, we believe there could be a better way. And for years, almost every person I ever spoke to who, has half a dozen or more machines, doesn't understand why hardware companies won't open up access to their printers. And I don't have all the answers. And some do, some don't. But what I would call for, or what I believe in, is a true agnostic scheduling software that can help optimize the 3D printers machines and the schedules. We believe that this can help application engineers move away from this data-intensive calculation process and focus again on knowledge-based decision-making activities. So depending on your company's goals, they can select the most optimal option for production on the shop floor. So what if you experience a build failure, or you've got a rush job and it needs to be pushed up, or a customer halts an order? What do you do now? Being able to proactively manage these obstacles in a very transparent and UI-friendly way helps everyone do their jobs better. By having multiple facilities connected into one platform and being able to see and understand the production and the planning on multiple facility levels will help you also reroute orders to other machines. Maybe a machine goes down and you have a custom critical part that needs to be made. If you can go to your sister facility, you can potentially drop that order there if the parameters in the machine is correct. I could talk about machine scheduling for hours and different ideas we have and where we're going in the future. But I think this is one of the most crucial pieces for companies who really believe in on-demand or the large-scale production for additive, is having an agnostic system that can communicate with all of your hardware. And you don't have to go and use 7 or 8 different types of software to plan out your builds and to collect data from your machines. And there's so much more you could do. I mean, once you have all of this ground truth data, you can actually take this information and filter it into a machine learning system that can improve your machine's build time and accuracy. And it can even start looking at things like the parameter sets. It can start looking at specific geometries and parameter sets that match to those geometries to recommend future build parameters. I mean, there's so much we could do. It's limitless if we have access to the actual machines themselves. So, if this last part matters to your industry, the fifth stage, we're looking at companies that are looking to print on demand with their internal facilities or their trusted suppliers. And they want to do this to reduce inventory costs and take advantage of the last mile delivery. With all of this, you can reduce transportation costs, you can increase your delivery speed, and provide local better customer support. So in doing this, companies must digitize parts for the print and essentially connect their systems, their machines in some type of network way. And by doing this, you can actually achieve on-demand distributed manufacturing. So ensuring parts can be printed with 100% repeatability is extremely important. And this involves secure and version controlled digital catalogs or digital part inventories that could streamline data to enable this type of production to become efficient. You can introduce things like blockchain or encryption into this process to make sure that your digital file, from the time it leaves your system to the time it's in your customer hands, is one, your design, and two, it was built with the exact parameters that you spent so much time and effort in developing. So the concept of a digital part inventory is something that we really love and focus on. So finally, as orders complete their production life cycle, continues to exist in our society. Build reports generated by our printers must be translated into some type of traceability report. And this is for many obvious reasons, but making sure that if a failure occurs, in a mission critical environment, that the market in the market, it becomes easy for companies to identify these high-risk production batches for recalls. Recall management is something that we believe blockchain and traceability reports can play a big role in. And this will help companies save costs across the supply chain and avoid major PR disasters. So wrapping up, I'm going to wrap up because I'm a little over the time I wanted to, but I think also being able to track data and analytics is extremely important. Without access to data and transparency across the production lifecycle, it's extremely hard for businesses to continually refine their 3D printing operations. And lastly, I just want to touch on software integrations. I think we all know they're extremely important, whether it's tied into CAD or PLM or ERP or all three. But once businesses can do this, they can truly connect the digital thread and achieve things such as streamlined workflows, automated data entry, the reduction of human errors. And companies can save time and invest these valuable resources where it matters most. So with the connected system, businesses can take advantage of BI tools that can help turn data into actionable insights. So in closing, here's my little pitch about Linked and our product. But we're currently working with hardware companies out there, both on the metal and polymer side, to make these integrations possible with the machine manufacturers. We're also working with software companies to access their APIs and truly connect the digital thread. As we all see, and we probably all know, the industrial workflow is fragmented, but there's definitely hope for the future. And I truly believe that if we all work together and people start collaborating more and we start setting standards for our industry, we'll really be able to connect the digital thread and achieve these promised benefits of Industry 4.0. And that's enough out of me. I feel weird because I'm talking to my screen, but Janet, are we going to open it up for questions?
Yeah, definitely. Thank you so much for everyone attending our webinar today. we now open the floor up for questions. So if you guys have any questions, feel free to type it in the Q&A box down there.
Janet, do you want to just read some of them to me?
Yeah, sure. So Kenny here is asking, do you offer any auto pricing tools today? If so, like, how does it work?
Yeah, Kenny, we do. Our system, something that makes our system quite unique, is its ability to be mappable, meaning customized. So if you've ever used Salesforce or an ERP or any type of mappable software, you could set the system up in the way that best matches your business workflow. So we do have auto pricing tools, and you can really customize this from having auto pricing be customer facing or have auto pricing be on the application engineering side, splitting up certain materials that have auto pricing versus certain materials that don't. It's done. A lot of it's our own IP, but it's done through simulation, calculation of materials, the machine parameter sets, and a few other factors is how we do it today.
Okay, cool. Sarah here asks, are you currently connected with any 3D printers today?
Yeah, so we are. We're actually working on several partnerships right now. What I can say is we will be fully integrated into GE machines and EOS machines in the next probably 6 to 8 weeks. So if you use EOS State or EOS or Predix, we'll be able to connect directly to them. And we're working on partnerships with other polymer and hardware companies as we speak. But we'll be rolling out the GE and EOS strategy probably mid of second quarter.
Thank you. We also have here Nicholas Frankie that's asking, what's the main difference between LINK3D and Authentize or other systems out there?
It's a good question. So actually, I love Authentize. Andre is a good friend of mine, and I think he's a brilliant guy and he's done an awesome job. I think there's a lot of differences between us. I don't want to get into what makes us better or what makes them better. I think it really depends on your business case and your application. Whether you're aerospace or automotive or you're printing in metal or polymer, what type of stage you're in, and also your pricing strategy. How do you want to pay for a system like this? So there's a lot of different questions. I think we should take that offline and have a separate conversation where we can really dive in to the differences between our solution and their solution.
Yeah. Another person asked here, thanks, John, asking about build planning. You guys are talking about optimization of build planning. I think he said that it's really important for him managing the shop floor. What do you guys currently have in place for optimizing build planning?
So who asked that question? I'm sorry?
John asked for it.
John? So currently what our system does, I have a little cold, so I apologize. What our system does is it takes a look at all of the orders that have been scheduled for production. And once orders have been scheduled, we use something like a heat map sensor that will essentially bucket or prioritize orders that could be built together on the same run. And we can always demo this to you, but essentially, parts that can be built together that have very similar parameters or geometry or the same material will have a darker color, and it'll fade out into a lesser of a color if the possibility of printing those parts is separate. So, and then once you select the specific orders that you want to add to your machine schedule, what we'll do is we'll give you several different orientation strategies. You could choose those orientation strategies. All the parts will be packed into the chamber. You can then take that file, script your support structures, and then send it to your machine while scheduling it simultaneously. I hope I answered that question correctly.
Yeah, thank you, thank you. You guys, really, really thank everyone for attending our webinar right now. I know it's 2:45. Shane, do you have a hard stop or anything? If you want, we can keep the floor open. Otherwise, we can reach out to everyone directly for the questions that were not answered today so that we can dive deeper into what your current state of the art is and if our additive manufacturing specialist can help you on your way to optimizing your 3D printing workflow.
Yep. Hey, Janet.
Yeah.
There's one other question I wanted to answer.
Yeah, for sure. Go for it.
So Oliver Wagner asked, what type of hardware do we support? So currently we support around 50 or 60 manufacturers of hardware. And I think we're close to like 500 different models. So what I'm looking at here, I think we support all of these. Maybe Keon's is one we don't. I don't know if I even know that, but everything else we support. So basically, if it's very mainstream, obviously like 3D Systems or EOS or Arcam or Markforged or Desktop Metal, we support those. And if we don't have your machine, we'll work with you to add that into our system. You're welcome, Oliver. So Janet, did we record this?
Yes, it's recorded. So Tios, no worries. We're going to send everyone, including yourself, a copy of the recording so they can go back to it. And if you have any questions, feel free to email us afterwards as well.
Okay, sounds good. So is there any more questions, Janet?
Just a little comment by Oliver Wagner here. He said, take a look at Keon's. It is a nice printer from Japan. Greetings from Germany. Thanks, Oliver.
I will check it out, Oliver. We actually have an office in Japan.
Yep, we do.
All right, I got to go to dinner now.
Sure, you can send the email. You can send the questions to Kenny at link3d.co. He's the person that is connected with all of you. If not, feel free to also email sales@link3d.co, and we can route you to someone that can answer your question. Thank you.
So thank you, everyone. Thanks, Janet.